Welcome to this video lecture on regeneration failures in Creo Parametric, and this is a lecture-only style video. There will be no demonstration. First, we'll take a look at the different causes of regeneration failures in Creo Parametric, then how to prevent regeneration failures, and finally, if you get a regeneration failure, how you can fix it. The primary cause of regeneration failures in Creo Parametric is bad parent-child relationships. So our models are parametric. Whenever you create new features, you have to reference existing features in your model, and that establishes a parent-child relationship. And parent-child relationships, when they go wrong, they end up causing regeneration failures. As you become more experienced in Creo Parametric, you'll find that certain features tend to fail in the same ways generally most of the time. So first we'll take a look at the common causes of regeneration failures for different features in part mode, and then we'll talk about some of the different causes of failures for components in an assembly. So first off, sketches. Sometimes you might change the sketch plane of a feature, and that'll cause the sketch to end up losing some of its sketch references. And what you'll have to do is edit definition of the sketch and remove the missing references, and then select new references, or you might need to replace references or update references. Then click the Solve button in the Sketch References dialog box to update the references. And another big cause is missing external references. And that often happens when someone uses the useEdge or project command in order to select references from a different model. Ideally, if you are going to reference geometry from other models in external references, you want to use a data sharing feature like a copy geometry feature or a shrink wrap feature. For rounds, a lot of times the cause of the failure for a round feature is that the radius is too large and it'll cause the round to overlap itself. And the solution in this case usually is to make the radius smaller. Also, if a round references multiple edges and those edges end up being removed from the model, then you will get a failure and you'll need to edit definition of the round and remove the missing references. And if you can, use intent references for rounds. With intent references, rather than selecting edges explicitly, you're referencing the edges associated with a feature, and if that feature shape ever changes, then the round feature will automatically update. And another typical cause of rounds failing is the transitions. So if you have multiple round sets intersecting, or you're changing how a round terminates in your model, the transitions can cause failure. So you might have to edit definition and either remove the transitions or change the transition types. For holes, number one cause of failures are missing references. And if you can, you might want to locate the hole from different surfaces or datum planes as opposed to dimensioning them from edges, because again, edges tend to be less stable references than surfaces or datum planes. Also, you have different depth options for a hole, and there's one that's called through until. I don't recommend using this option at all. It's an older option. There's a newer option called to selected. The problem with through until is that your hole has to completely intersect the reference that you select. With to selected, you don't have that restriction. With to selected, whatever you're using as a reference will be extrapolated as necessary, so the depth of the hole will be defined. But that doesn't hold true for the through until option. I really don't see any point in using through until when you could use to selected instead. For draft features, well, draft is going to be placed on different surfaces, and if those surfaces go away, then the draft feature is going to fail. And just like with rounds, you want to use intent references where you can, where you're drafting the surfaces associated with an earlier feature in the model rather than selecting surfaces explicitly. With shells, they can fail if the thickness is too large and the surfaces end up intersecting itself. There are some options in the dashboard for the shell feature that allows you to handle those failing surfaces, but you might want to use a smaller value for the thickness. And if you can't do that, then you can essentially do a shell feature manually by using the offset command. You offset a number of surfaces and then merge them together, and then use the solidify command in order to generate essentially the same result of a shell. With ribs, specifically profile ribs, if the arrow for the direction for a material being added points to the wrong side, then you're going to end up with Creo Parametric trying to basically add material out into empty space, and that'll cause a failure. So all you need to do is flip the material side. Also, profile ribs require an open sketch, and if that sketch is no longer attached to part geometry, then the rib feature will fail. For extrudes, we already talked about the through until depth option. Again, if you can use two selected, use that one instead. Another cause of extrudes failing is if you have an open sketch and it extends beyond part geometry, that can cause a failure. So instead of using an open sketch in that situation, you might want to close the sketch or change the depth options for that extrude feature. All right, for patterns, if you're duplicating features, there are different options available. And the interesting thing is identical used to be the default option. Now general is the default option. Just a little word on the little explanation of those different options. With identical patterns, all the instances have to have the same shape as the original feature. You can't vary the dimensions associated with it. And also all the instances have to be initiated from the same surface as the lead feature. With the varying option, you can change the dimensions associated with the instances. So for example, they could get taller, or they could get diameter could get bigger as you're creating the different instances, but they still have that restriction that they have to initiate from the same surface as the lead feature. The general option for patterns is the free-for-all. You can have the dimensions change for the different instances, and the instances can start from other surfaces or can start from empty space, and it's the least restrictive. And a few years ago, the general option became the default. The problem with the general option is that they can take longer to regenerate. So if you are trying to improve model regeneration, you might want to change to varying or identical if you can, but be aware when you do that, you are increasing the chance of having a regeneration failure. All right, some more features in part mode. So with blends, you have to make sure that you have the start points line up the way that you want. If you get the start points not lining up, then you're going to get twist in the feature. And if there's excessive twist, then the feature can fail. Another cause of blends failing is that you have to have the same number of vertices in each section. And if somehow the section changes, so has a different number of vertices than the other sections, then you'll get a failure, and you'll either need to change the section to have the same number of vertices or designate some vertices as blend vertices to have two vertices converge down to a single one. And also the boundary conditions can sometimes cause a failure. So with a blend feature, if the first and or last section uses model geometry, then you could define a tangency condition or a normal condition. But again, if that geometry that is being used to define the first or last section changes, it can make impossible geometry for that boundary condition. So you might need to change the boundary condition to free or change the underlying geometry that's being referenced. All right, for sweeps and swept blends, there used to be a restriction against self-intersection. A sweep or a blend or swept blend as they were moving along the trajectory was not allowed to intersect itself, but I've noticed that this no longer holds true. However, I've not been able to verify if you were to open up a model that was created in an earlier version of Creo Parametric or Wildfire or Pro Engineer even, and change the sweep feature so that it self-intersected, if it still had that robustness as in later versions of Creo Parametric. All right, boundary blends. These are features that are creating a surface from a network of curves in one or two directions. And if those underlying curves either change or are deleted, then that will cause a failure to the boundary blend. And just like with the blend feature, you can apply different boundary conditions on the borders of the feature. And again, those boundary conditions can sometimes result in the failure. All right, surfaces, just surfaces in general. They can be affected by your model's accuracy. And actually, this applies to all different features in your model. And accuracy refers to the smallest curve length that Creo Parametric is capable of seeing. And I note surfaces in here because I've encountered this a lot when I'm trying to do an offset command. So for example, if I have a really big surface and I'm trying to offset it a small value to represent the thickness of a component, if that accuracy isn't set correctly, then you can end up with a regeneration failure. And it'll be really frustrating because you'll be looking at the model and you're saying, hey, this should absolutely work. Why isn't my feature working? And it's because of accuracy. And in general, you should use absolute accuracy, and you should figure out for your different applications what accuracy value to have. Ideally, you have the same absolute accuracy in all your different models, especially all the models in a given product. And one last thing to mention, relations. Relations are the mathematical expressions or equations that you set up so that you drive some features by other feature dimensions or parameters. And again, relations, that's something that can end up causing a failure. So you might need to comment out relations or update relations if you're getting failures. All right, let's talk about the causes of components failing in assemblies. And first thing, missing components. So when you open up an assembly, Creo Parametric is going to look for the component in 4 different locations. And this is assuming that you're not using a data management system like Windchill. First, it'll look in your computer's RAM. And if it doesn't find the component in the RAM, then it's going to look in the working directory that you've designated. The third place it looks for the components is in the directory from which you opened up the assembly, if that directory is different than the working directory. And also you can have different search paths set up where you have different libraries of components. And if it doesn't find the component in those 4 different places, well, then you're going to end up with a regeneration failure. And the component will be highlighted red in the model tree, and you can right click on it and choose retrieve missing component and try to locate where it might be in your computer. All right, another cause of failures in assembly mode, missing references. And what I mean by that is that when you assemble a component, you use different constraints like coincident, distance, parallel, normal, and so on, tangent. And you have these different constraints, and you select geometry from the component that you're assembling and from existing components in the assembly. And if those references that are used for those constraints go away, then you're going to end up with a regeneration failure. And speaking of constraints, if you use the fixed constraint in conjunction with regular constraints like coincident or distance or parallel or normal or tangent, and the geometry that you're assembled to changes, that fixed constraint is going to end up causing a regeneration failure. And that's similar to invalid constraints. So for example, if you change a component, either the component that is being assembled or what the component is assembled to, and you result in a mathematically impossible solution, then you'll end up getting a regeneration failure. Now that we've talked about the different typical causes of regeneration failures, let's talk about some ways that you can prevent them to begin with. So in parts, if you can create dimensions to surfaces or datum planes instead of edges, that tends to reduce regeneration failures because surfaces and datum planes tend to be more stable references than edge references. And along those same lines, when you're creating rounds and chamfers, instead of selecting edges for the rounds and chamfers, if you can create a surface to surface chamfer or round, that tends to be more stable. Also, sometimes when you're working in sketch mode, you go to delete an entity and you'll get a warning that says, hey, this entity is referenced by other features. Do you want to continue? What Creo Parametric is telling you in that moment is that if you delete that entity, then you're going to get a regeneration failure after you get out of sketch mode. And so what you can do is, rather than deleting that entity first, you can replace it with another entity. And that replace command is available from the operations overflow menu in sketch mode. And operations replace will transfer the children of that sketched entity to the new entity that you select, thereby preventing a failure. Intent references. I've mentioned intent references a couple times. Intent references are really powerful for features, and that's where you are referencing the geometry associated with a feature as opposed to explicit edges or surfaces. And intent references are more robust than explicit references. Another one, suppressed objects. Sometimes people will keep suppressed objects in their model, and then later on someone might resume all the suppressed objects in your model. They'll cause conflicts with existing features, and you'll end up getting regeneration failures. And so in general, I recommend definitely before you release a model, you should get rid of any suppressed objects. In general, you should avoid any kind of long-term saves with suppressed objects. And another thing to help prevent regeneration failures in parts is using model check. In model check, you can configure it with different rules to ensure that you are not using bad practices. And you can also configure model check to give you warnings if you're doing certain things that could potentially result in failures in the feature, such as having suppressed objects or having early rounds in the model. In assemblies, probably the best way to prevent regeneration failures is using top-down design. So rather than assembling components to one another, you could use a skeleton model and have the components assembled to a skeleton. And that way, if a component gets deleted or changed, then the other components that are assembled to the skeleton aren't going to fail. And another way to help prevent regeneration failures is that you should make external references only to a skeleton model. And that's a kind of loose rule. I generally say if you have an assembly of under about a dozen components, it's okay to make external references using data sharing features between components. But really, ideally, especially for complex models, you should only be making external references to a skeleton. The skeleton should have all the geometry that needs to be referenced by multiple different components. Now let's talk about how to solve regeneration failures. And the first thing I want to mention, don't panic. Sometimes when people get a regeneration failure, they overreact. They act like it is the end of the world. And I know that I am mixing Hitchhiker's Guide to the Galaxy with a little bit of Star Wars here, but if you get a regeneration failure, take a deep breath. It's really not that big a deal in the grand scheme of things. So don't get angry, don't get scared. Just take a deep breath and deal with the issue. So how do you solve the problem? First, you want to identify what's failing. And probably the easiest way to do that is by using the model tree. You can see the failed feature in bold red in the model tree, and the children of the failed feature that are also affected by this failure will be in a faint red color. But you want to look for the bold red. Also, you could use the notification center to figure out what's failing in the model. There will be a little red flag down in the bottom of the screen towards the right-hand side. So now that you know what's failing, you want to figure out why it's failing. And one thing that you want to do is just educate yourself on the feature. So you could right-click on the feature and choose feature information and just read through it. It's like, hey, what kind of feature is this? Because once you know what kind of feature, well, features tend to fail in the same ways all the time. So you want to see what kind of feature it is. And another thing that you want to know is parents. Parent-child relationships are the number one cause of regeneration failures, so it helps know what are the parents of this feature. And you also just want to familiarize yourself with the different options that were used to define the feature and maybe other information like the dimensions, because we know that the values of the different dimensions, sometimes if they're too big, can cause features like rounds and shells to fail. Another tool to help you identify why it's failing is the reference viewer. And the reference viewer allows you to examine both the references, in other words, the parents and children of a feature, as well as dependencies. And also, you can edit definition of the feature, and typically you'll see in red, maybe one of the tabs or one of the different collectors will show red to indicate that there's a problem in that specific area. And third step, you want to fix the failure, and that means either editing the definition of the feature or editing definition of the parent. You might even just need to edit values in the model, but if you follow this 3-step process, you should be able to take care of any regeneration failures that you have. I hope you enjoyed this video. For more information, please visit www.creowindchill.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.